the function, take a moment and say, okay, I know what to do. Can anyone give us an idea? Caitlin, please.
Can we multiply by the reciprocal of x plus 2, which would be square root x minus 2, onto both?
I cannot change this. This cannot be changed.
Then it's plus 2 at the end.
That's it. Awesome. We rationalize the denominator. Great job. Thank you very much. The limit operator does not get dropped. Okay, perfect. We always keep everything in the descending order. So the 2 minus x will factor out a -1, and it will be x minus 2. I will multiply by the numerator that we just came up with. And now, can anyone multiply for us this by this? This is what we did on the first day of classes. Isaac, would you try, please?
Is it to expand it?
The formula is a minus b times a plus b. That was the first thing we did.
What?
I'm sorry?
Sorry, I can't really hear.
So
the formula is
a minus b times a plus b. The first thing we did on the first day of classes.
a squared plus b squared.
No, that a squared plus b squared is not factorable.
I meant minus.
Exactly. Very good. So what should I write? Awesome.
Should write
Yes?
root x plus 2. Wait, is x plus 2?
Excellent. No, just x plus 2. Yes, the square root squared is x plus 2. And then? Good.
4 minus 4.
Excellent. Great job. As you see, this turns into x minus 2. So I'm going to write it again. Don't simplify right there. So this is my page 2. So this equal symbol, I always put the equal symbol so you know something else follows. So look for it in the next page. Good. So then we have negative x minus 2, the square root of x plus 2 divided by x minus 2. Can anyone tell us what to do next? Good job. Yes, Caitlin, go ahead, please.
The x minus 2 and the x minus 2 in the denominator and numerator.
Good, excellent. Who else would like to tell us what to write next? Apply the limit and give us the answer, please. How much?
Why didn't the square root cancel out on the top?
How? First of all, I cannot simplify in a sum because this is a sum of two terms. And then what will I simplify the square root by? If I cancel something, I have to cancel another quantity. Where do I cancel it from? Is it clear what I'm saying?
All right, I think my connection's bad. I'm not at home.
Okay. So can anyone give us the answer, please? Anyone? Yes, Caitlin, please.
Would it be 4? The limit of x as it approaches 2 would be 4. Oh, negative 4.
Excellent. Gorgeous. Well done. That's it. Okay, so now I highly recommend do as many problems as possible from the odd number ones. All the answers are right there in front of you. And let me know if you want to work on other examples. I'll be more than happy to choose other examples. Okay, now I would like to talk about what it's called the squeezing theorem. Or the squeeze theorem. Okay. So here's the idea. Let's suppose we have a function that is f of x. Let's see, we have a value here for x, which is a. Let's say I have another function that does this, and this is g of x. And I have now the red function whose limit I would like to determine. I'm going to call it h of x as x approaches a. So you can say, where is h? It's not f and it's not g. So h is somewhere here. This is h of x. Notice that when we are talking about the limit from either side, we really mean it, right? It approaches a. X approaches a. And we're only looking at this interval right here. I'm not looking here. I'm not looking here. I'm only looking right here, where x approaches a and the function value h approach this. I'm going to denote this by L. Notice one thing. Number one, that we can say that h of x is sandwiched or squeezed, right, between f of x and g of x. We don't write it like this. We write it like this. But it's very important. Near a. Not everywhere. We're not interested in everywhere. I'm interested in the vicinity of a. And then in number two, obviously I see that the limit of f of x as x approaches a equals the limit of g of x as x approaches a, and they equal L. So here is f, here's f with a limit, here's g with a limit. Then from 1 and 2, what do you think we have the conclusion by the squeeze theorem? What can we say guaranteed about the limit as x approaches a from our function, not these functions that we are not really interested in?
Would it be somewhere in the middle or equivalent to the other two since it's in between them?
Correct. So what do I have to write? Excellent idea. So what do I write?
Limit of h of x equal L?
That's it.
L?
By the squeeze theorem, this is guaranteed. As long as I can show these are two hypotheses. H of x squeezed between the lower and the upper. The lower and the upper have a limit, and the limit is L. By these two, and by the squeeze theorem, from these two and by the squeeze theorem, the limit is L. When will this apply? The question is when it will apply. In a situation in which nothing else applies. And let me give you a couple. So I'm going to squeeze. I'm going to share squeezing my my computer here. Okay, so I'd like to start with this one. They already give us the answer, but I'm not going to look at it. Okay, so I'm going to copy 41. Limit s of x to the fourth cosine 2 over x as x approaches 0. Okay, now I'm going to stop sharing. Okay, so here's the problem. We're asked to determine the limit. What do we have to do first? What is the first step whenever we calculate a limit?
Plug it in.
Absolutely, thank you very much. So when we plug it in, piece by piece, this is a product. Where does this go?
0.
Excellent. Where does this go?
2/0.
We have the graph. That's why we graphed 1 over x or 2 over x is the same thing. Where does this go? You could say, well, be specific, because from the left is one thing, left of 0 is one thing, and from the right of 0 is something else. But you can also say, because we know the graph, right? Now, if I need to graph these, I will, but I'm just hoping that you make a table of and summary of everything we studied every day. So this is the graph of 2 over x or 1 over x, same graph. So this is basically D and E, right? And now if I ask you how much is cosine of D and E, you're not going to have an answer. There is no answer. And 0 times no answer, you cannot conclude that it's 0. Okay? Okay, so this is a situation in which the squeeze theorem is applicable. But the squeeze theorem, as we know, has part 1 and part 2. If I cannot show part 1 and part 2, the squeeze, the sandwiched, and the limits, then I cannot conclude anything. So let's look at the first part. And we're going to try to build this piece by piece. And we are going to always start with a trig function. So forget about this for a moment. And let's start with the cosine. What do we know about cosine? And that was sometime last week or 2 weeks ago. Can anyone tell us what we know about cosine? Something very special.
Originates on the y-axis at either 1 or -1.
Not cosine, but you are on the right track. It has a maximum of a 1. Excellent, that's really all I wanted. But cosine is measured on the x-axis. Is the adjacent leg, right? Awesome, that's what I wanted. Do we all understand this, everyone? Is that a yes or a no? Yes, perfect. Okay, so I do have this piece, but what should I do here to all 3 sides to get this function in the middle? What should I do to all 3 sides, not to 1 or 2, to all 3 sides to get this function in the middle? What do you think?
Add x raised to the power 4. Or
But
multiply it.
Exactly, I completely agree. Thank you very much. Awesome. Yes. So then this becomes negative x to the 4th. This becomes x cubed times cosine 2 over x, and the right-hand side is x to the 4th. Perfect. Awesome. Thank you. Now, do I have this function in the middle? Our function is in the middle. From the theorem, we denoted that by h of x. How do you want to denote these two? You have it in your notes if you take notes, right? What did we say about
f and g of x?
Excellent. So the first step is fulfilled. We squeeze the function between 2 other functions. Now step number 2, we have to find the limit of f of x, of course when x approaches 0, and we have to find the limit of x to the 4th as x approaches 0. I want to make a comment here, come back to this x to the 4th. When we multiply all sides, both sides or 3 sides of an inequality by a quantity, we have to make sure that this is not 0, and we also have to make sure that it's positive. Because if it's negative, I have to switch the inequality symbols. Can this be 0?
Yes.
What did we say about this a long time ago?
It can't be 0.
It cannot be 0. By definition, it cannot be 0. So this is fulfilled. Is it positive? Is x to the 4th positive?
Yes.
Yes, x to the 4th is always positive. Well done. Great job. Okay, good. So then what we did here was legitimate. It was never 0, because if it's 0, I'm not allowed to multiply. And it's positive, so I don't have to switch the inequality symbols. Good. So first step is completely fulfilled and discussed and analyzed. What is this?
It would both equal 0.
Excellent. Great job. So by 1 and 2 and the squeeze theorem, what do we conclude? What do we conclude about the limit of x to the 4th cosine 2 over x as x approaches 0?
Equals 0.
Excellent. This is it. This is the way we apply the squeeze theorem in a problem that we cannot, on a limit that we cannot determine in any other way. Excellent. Now I would like to work on one more problem before we continue, unless you have questions. Remember, questions are always, yes, any questions?
I have one question.
Yes, please.
Oh, based on the squeeze theorem with the limit of, what was it, f of x equaling limit of g of x, does that mean that in those cases the graphs would have to intersect at least one point?
They have to be close so that the limit is the same.
Okay.
Yes. Otherwise, what we wrote here is not going to be valid.
Yeah.
So we showed that everything is valid. That's why the limit is 0.
Okay, thank you.
Very good. Other questions? Anything else? Okay, I'm sharing my screen, so let's take a look at something even more important to understand the squeeze theorem. If I find it. Yes, I did, right here. Here it is, 39. So in 39, as you see, are we given the function? Do we have the function in 39?
We do not.
We do not. And we will still be able to find a limit for a function that we don't even have. How? Using
The squeeze theorem.
using the squeeze theorem, which is another important application of the squeeze theorem, which we would have not been. If you don't give me the function, how can I determine the limit? But the squeeze theorem has that capability. So I'm going to copy 39. So 4x minus 9 less than or equal to f of x less than or equal to x squared minus 4x plus 7 for all x greater than or equal to 0, and 4 is greater than or equal to 0, so they are asking us to find the limit as x approaches 4. This is a much easier situation. How come?